Today we'll be learning about turning point of quadratic functions. Now before we start learning the topic on how to find the turning points, we should have some prior knowledge about what a quadratic function is. When you plot a quadratic function into a graph, you get a shape like this, or a U. You can say a U or an inverted U. This is the shape of a quadratic function on a graph sheet, and the shape is called a parabola. Now it is clearly visible that by the word turning point, we are trying to find a point where it turns. Okay, so this is going to be a turning point. And from here you can see this is again another turning that the curve takes. So this is going to be another turning point. So you have two turning points. Now at the peak you call it the maximum point, and at the sink here you call it the minimum point. Moving on to the next. You should know the forms in which a quadratic function is written. The standard form, which is f of x is equal to ax squared plus bx plus c, and a not equal to 0. The vertex form, which is f of x equal to a x minus h the whole square plus k. Now what is h and k? H and k stands for the coordinates of the turning point. So it can be either a maximum point or a minimum point. Taking you to the figure, this is h comma k, and this is again h comma k, where h is the point on the x-axis and k is the coordinate from the y-axis. Now talking about the value of the gradient at the turning point, here you can see a positive gradient, and the function here shows a negative gradient. And at this point you can see the change of gradient from the positive to the negative. At this point the gradient is equal to 0. And this is the same condition here. You see the negative gradient at this part, and the graph takes the turn here towards a positive gradient. And at this point where you have the minimum, the gradient is equal to 0. So these are some things which you have to remember before we move ahead. Moving to the main topic, which is how to find the turning point of a quadratic function. We'll have two methods discussed here. I'll start with the first one. Method 1, using completing the square. Now the method completing the square is not new if you have learned how to factorize a quadratic expression using the completing the square method. If you're not familiar with it, or if you have forgotten how to do it, use the link above and take a few minutes to revise it and then come back to this topic. Now let me explain the method using a function f of x is equal to x squared minus 6x plus 2. You can see that you cannot have the sum and product of splitting the middle term to factorize this expression. Looking at the negative term here, negative 6x, I know my identity is going to look like x minus a the whole square. Let me quickly remind you that is going to be expanded as x squared minus 2ax plus a squared. Now what is a? You have minus 6 here, so I'll be just quickly dividing 6 by 2, which gives me a 3. So I will proceed further with writing x squared minus 6x plus 3 squared minus 3 squared and the plus 2. The new terms that I have introduced is a plus 3 squared and a minus 3 squared, keeping the remaining function just the same. Now to complete my square, I just need these three terms, giving me x minus 3 the whole square. So you can see that if you want to cross-check, when you expand this, you get these terms back. And dealing with these terms separately, this is minus 9 plus 2. So my answer will look like x minus 3 the whole square minus 7. After finding your answer in this form, you have to compare it with the vertex form of the quadratic function, which is x minus h the whole square plus k. So by comparing, you can see the h takes the value of 3 and it's a plus k, so k takes the value of minus 7. So you have got the vertex h equals 3 and k equals negative 7. So the coordinates of your turning point will be 3, negative 7. Moving on to the second method, which is by finding the first derivative. Now again, if you're not familiar with how to find the first derivative of a given function, sharing the link for the video where you can just have a recap and then come back to this session. I'm using the same function f of x equals x squared minus 6x plus 2 as in the previous method. Now here, first I'll be finding the first derivative, so which is 2x minus 6. And I know at the turning point, my gradient function f dash of x will be equal to 0. Now using these two conditions, I will be equating 2x minus 6 equal to 0 and finding the value for x, which is x equals 6 by 2, giving me a 3. Now x equals 3 is the x coordinate of the turning point. Now once I get the value for x, I will be substituting this into my f of x equals x squared minus 6x plus 2. Why? You should remember that f of x is nothing but the y. So y is x squared minus 6x plus 2. It just means the same. Y equals x squared, my x is 3. So 3 squared minus 6 times 3 plus 2. Let me remind you of one of the common errors seen where students tend to shift this or tend to replace this x into the gradient function. Please remember this is f dash of x. We need the value for f of x, which is your y. So this is going to be 9 minus 18 plus 2, which is minus 9 plus 2, giving you a negative 7, which is exactly the same answer that you get in this method. So the turning point is going to be 3, negative 7. This is the answer. A graphical view of this will help you better understand what is happening. Now I have used the Desmos.com. Desmos is a platform where you can graphically visualize your functions. And you can also use this link. I have shared it at the top. Now I have put y equals x squared minus 6x plus 2 and I got the parabola, and it's the same thing. I've just zoomed in and marked this point. So this is 3, negative 7, which is the turning point, and this is a minimum point. The first part of the video was to find the turning point of the quadratic function. Now the second half is where you're going to find the nature of the turning point. By using the word nature, we just want to know whether is it a maximum turning point or a minimum turning point. The method 1 that we can use is by looking at the value for a in the standard form. Now we know what is the standard form, which is ax squared plus bx plus c. So in the standard form, how can we look at a and decide whether it's a minimum or a maximum point? See, if your y is in the form ax squared plus bx plus c, you can see A is plus 1, B is minus 6, and C is 2, plus 2. If you look at the value for A, when A is a positive coefficient, or if you have a positive number there, then remember it's going to be a happy face. So A positive, which means you have a happy face, a parabola which is like a U. And the point here is a minimum point. So the summary is, if A positive, it's going to be a minimum point, a minimum turning point that you're going to get. And if A is negative, remember negative, it's a sad face. And then you get a maximum turning point. This is a maximum point. So just by looking into the function, you can decide the curve that you're going to get, whether it's a U or an inverted U. So the nature of your parabola can be found by looking at the value for A. Here's an example for it. Here A is -1, and see here, this is your maximum point. You have two more methods that can be used, which is using the gradient function and by using the second derivative. So in method 2, we'll be using f dash of x, or you can say dy over dx. And for the method 3, we will be looking for the second derivative, which is f double dash of x, or you call it d square y over dx square. I'll use the same question as before for f of x is equal to x squared minus 6x plus 2. And we have already found the turning point to be 3 and -7. So using the gradient function, I will find f dash of x first, which is 2x minus 6. Now we know that f dash of x is, the gradient is equal to 0 at the point 3, -7, which means when x is 3, you have a gradient 0. Now I'll take two values, less than and more than 3. So I have taken 2 and 4 here, and let me substitute these values into the gradient function. So f dash of x equals 2 will be 2 times 2 minus 6, giving me a 4 minus 6, which is -2. And f dash of x equals 4 gives me 2 times 4 minus 6, which is 8 minus 6, giving me a +2. Now from these values, I realize that you have 3 in the middle, and when you have 2 and 4 here, so the gradient at the coordinate x, this is the x-axis, okay. The gradient at the coordinate when x is 2 is negative. So that means this is how the function should be. It becomes 0 here, and you can see at 4 it is a positive gradient, so it's moving up. So the gradient is minus, 0 and positive. This tells me that this is going to be a minimum point. So this is the way you're going to check if you're using the gradient function in method 2. Now let's see how can we find the minimum point using the second derivative. The key condition that you're going to check here in method 3 is that if f double dash of x, which is the second gradient, is greater than 0, it's going to be a minimum point. And if f double dash of x is less than 0, less than 0 means negative, it's going to be a maximum point. So remember, greater than, if it's a positive value, it's going to be minimum, and if it is a negative value, it is going to be a maximum. It's slightly confusing, but you're taking the opposite thing. If it is positive, minimum; if it is negative, maximum. So let's just work it out. Now for the function f of x equals x squared minus 6x plus 2. F dash of x is equal to 2x minus 6. And f double dash of x, which is the second derivative, is going to be 2. Now 2 is a positive value. Here we can see that 2 is greater than 0, which means f double dash of x is greater than 0, and the condition is that this is going to be a minimum point. So these are the two techniques that you can use to find the nature of the turning point.